Hi folks, we're going to take a look at number 17 from page 245 from the assignment. So they want us to find the exact value of cosine of 13 pi over 12. Okay, so I look at this angle here and I realize that it's not itself a special angle, but hopefully we can write it as a combination of special angles, in particular a sum or a difference of special angles. So we can use our compound angle formulas. Okay, so one thing you might do is to first just write these special angles all using the denominator 12. So it'll be easier to see the combinations you might use. Okay, so you've got pi over 6. Instead of writing it as pi over 6, you can write it as 2 pi over 12. Okay, and instead of pi over 4, that's 3 pi over 12. And instead of pi over 3, that's 4 pi over 12. Okay, and I see here that no combination of any two of these will get me to 13 pi over 12. Okay, so that means we're going to have to go beyond the first quadrant. Okay, so if I go to the second quadrant, well, I can go to 2 pi over 3. Okay, which is 8 pi over 12. Still no combination that's going to work. So let me go now to 3 pi over 4, which I'm going to write as 9 pi over 12. And here finally I see a combination that's going to work. 9 pi over 12 plus 4 pi over 12 gives me 13 pi over 12. Okay? So I'm going to rewrite this expression as the cosine of pi over 3, because that's 4 pi over 12, plus 9 pi over 12, which is 3 pi over 4. Okay, so I've written it as a combination of two special angles. Okay, and now I'm going to apply the compound angle formula. So I know this is cosine of the first times cosine of the second minus sine of the first times sine of the second. Okay, now before I go and calculate this, let's just see where 13 pi over 12 lives. Okay, so 13 over 12 is slightly more than 1. So this angle here would be slightly more than pi. So that means it's in the third quadrant. So we expect the final answer here to be negative. So that's a good way of checking your answer. If you don't get a negative answer, you must have made a mistake somewhere. Okay? So as you're calculating these, again, unless you know them all really well or you can imagine them in your head, draw yourself a little picture. Okay? So we've got 3. Sorry about that.
Bit of a break in the software here. So here, let me start again. 1, 2, root 3 for pi over 3, and then for 3 pi over 4, okay, we have negative 1, 1, root 2. Okay, so now I can use these to quickly write down my trig ratios. Okay, so cos of pi over 3, so that's 1 over 2, times cosine of 3 pi over 4, so that's negative 1 over root 2. Okay, minus, okay, sine of pi over 3, root 3 over 2, times the sine of 3 pi over 4, 1 over root 2. Okay, and now it's just a matter of simplifying this here. So here we have negative 1 over 2 root 2 minus root 3 over 2 root 2. Bring together these two fractions, so negative 1 minus root 3 divided by 2 root 2. Okay, and we see here that this is definitely a negative number, and so that makes sense. Now, I'm okay if you leave your answer in this form here, but say you did want to rationalize it or you want to compare it to the answer in the back of the book. Let's go ahead and do that as a reminder. Okay, so in order to rationalize this, you need to get rid of the square root in the denominator, and we're going to do that by multiplying both numerator and denominator by root 2. So negative 1 minus root 3 times root 2, and then 2 root 2 times root 2. Okay, so in the numerator, we end up with, distribute that, so negative root 2 minus root 3 times root 2 is root 6. And the denominator, well, root 2 times root 2 is 2, so 2 times 2 is 4. And that would be the answer in rationalized form. Okay, so just to quickly recap here, okay, when you find an angle that doesn't fit one of your special angles, you try to write it as the combination of special angles, okay, and those special angles won't necessarily
always be in the first quadrant. And one way to see that more easily is to rewrite your special angles using whatever denominator is given in the expression.